Not 10, but 12, by William Benjamin Smith. This is recorded to celebrate the 10th anniversary of LibriVox. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Not 10, but 12, taken from the journal Science, from Friday, September 12, 1919. There has come to my hands a petition in the form of an open "Letter to Lord Balfour, Chairman on Weights, Measures, Coinage, etc., circulated in the name of the World Trade Club, and calling upon United States American President, His Excellency Woodrow Wilson, United States American Congress, etc., and British Premier, His Excellency David Lloyd George, Houses of Parliament, etc., for legislation, promulgation, orders in council that will bring about the exclusive use of the meter, liter, gram by the United States of America and the British Isles. As the matter is of far-reaching scope and prime importance, may I be allowed a word of earnest protest. The reasons advanced in the 15 pages of argument, on disregarding the ill-advised and ill-founded appeal to national prejudice against the alleged Germanic character of our present system, or chaos, amount merely to the oft-repeated affirmation that the metric system, being consistently decimal, is far simpler, more convenient, and time-saving than any non-decimal system, since reductions from unit to unit are made merely by shifting the point, as in dollars and cents. That herein lies a certain very considerable convenience is not denied in any quarter and needs no detailed exposition. Also the advantage of world-wide uniformity in weights, measures, and coinage are plain and uncontested. But this latter fact is no reason for the Anglo-Saxon world to pass over to the Latin-German system, rather than for the latter to yield to some far superior system of the former. While conceding all that may be said with any show of reason in favor of a decimal system, we must not forget nor disguise the very grave disadvantages that inhere ineradicably in it, especially in its cumbrous expression of many simple, important, and frequent fractions, as 1/3, 1/4, 1/6, 1/8, 1/9, 1/12, etc. We protest most earnestly against the adoption of the Latin-German system, not because it is not better than our present lack of all system, but because such adoption would postpone perhaps forever the introduction of a far superior system, which is a capital desideratum of our modern civilization and life. The meter, liter, gram is at least in some ways comparatively good, but the good is the enemy of the best, with which we can only rest content, and it would be an infinite blunder to establish and eternize such a defective system as the M.L.G. when it is almost as easy, at least when it is entirely possible, to introduce and establish once and for all time the best system that the nature of number and of the human mind permits. This best of all numerical systems is not the 10 system, which is recommended only by the fact that man has 10 fingers and 10 toes, but the 12 system, whose virtues are embedded in the nature of number itself. Its notation requires at once the introduction of 2 new symbols, one for 10, one for 11, which may be made as pretty and simple as you will, but the initials T and E will answer all present purposes. We shall have then the ciphers 1, 2, 3, 4, 5, 6, 7, 8, 9, T, E. 12 is then to be written 10, and we shall have the next set 1, 1, 1, 2, 1, 3, 1, 9, 1, T, 1, E, 2, 0, to be read tel 1, tel 2, tel 3, tel 9, tel 10, tel len, twentel. The reasons for such names are obvious. Tel and len are natural simplifications of 12 and 11. Our present forms, such as 16, 17, which read the numbers 16, 17 backwards, are a stumbling block to beginners, hindering and confusing them to no purpose whatsoever. Twentel, 20, equals of course our present 24. Similarly, thirtel 1, etc., fourtel, fiftel, sixtel, sistel, centel, for 7-tel, 8-tel, 9-tel, 10-tel, len-tel, tel-tel, this last 100 equal to our present 144 is of course the second power of the base 12, 10, and should have some appropriate name, as dipo or tupo, or whatever may seem best, and similarly the higher powers, as 1000, 1728, 10000, 20,736, etc. We see here at once the greater power of this system. With 4 figures it expresses numbers up to 20,735 in the 12 system, more than twice as many as are so expressible at present, an advantage that steadily increases with the numbers, and shows itself clearly in logarithmic and other tables, where, with the same number of figures, the accuracy of expression would be sensibly higher. Thus a unit in the 6th decimal place now signifies a millionth, in the tel system it would mean about a 3/millionth. In the billions the tel notation economizes 1 place. Among the many advantages shared by this system with no other, the chief is the high factorability of the base 12, divisible exactly by 2, 3, 4, 6, and simply related to 8 and 9. Thence result extremely simple expressions for the principal fractions. 1/2 equals .6, 1/3 equals .4, 1/4 equals .3, 1/6 equals .2, 1/8 equals .16, 1/9 equals .14, 1/12 equals .1, 1/14 equals .09, 1/16 equals .08, 1/20 equals .06, etc. The fractions 1/5, 1/7, 1/10, 1/11, 1111, etc. remain indeterminate series, but for them we have little practical use. With the foregoing compare the current decimal expressions for the fundamental constantly recurring fractions. 1/2 equals .5, 1/3 equals .33333 repeating, 1/4 equals .25, 1/6 equals .16666 repeating, 1/8 equals .125, 1/9 equals .1111 repeating, 1/12 equals .0833333 repeating, and the great superiority of the tel system becomes evident. The multiplication table becomes markedly simplified. No one has any trouble now in multiplying by 5 because of its simple cycle, 5-0, as in 5, 10, 15, 20, etc. 4 has the much longer, more involved cycle, 4-8-2-6-0, as in 4, 8, 12, 16, 20, etc. 6 has the cycle 6, 2, 8, 4, 0, 6, 12, 18, 24, 30. 8 has the cycle 8, 6, 4, 2, 0. Compare with these the cycles in the tel system. 2, 2, 4, 6, 8, T0. 3, 3, 6, 9, 0. 4, 4, 8, 0. 6, 6, 0. 8, 8, 4, 0. 9, 9, 6, 3, 0. And the surprising simplicity of this system is again apparent. A child will learn this multiplication table with much less effort than the 10 table, and will find the range of its power and the scope of his attainment just 44% greater, since 100 in the tel system equals 144 in the 10 system. The year is divided into 12 months, and no other division is likely within any foreseeable time. Accordingly, in time reckoning the advantages of the tel system are obvious. In this notation the number of days in the year is 265. To each month we should by all means assign the same number of days, 30, 30 as now, or 26, 26 in the tel system, that is, 260 month days in all. The remaining 5 should be extramensual, legal holidays, easily and instructively distributable over the year, with a 6th such in leap years. Monthly and annual accounts and rates would be turned into each other by merely moving the point one place to the left or right. If one received $100 a month, one would receive $1,000 a year. If the interest rate was 6 per dipō per year, it would be .6 per month. Similarly, the day is already divided into twice 12 hours, that is, 2-0 in the tel system. The circle, or round angle, is now divided into 360 degrees, or 250 in the tel system. This Babylonian division is unfortunate, but may be easily conformed to the divisions of the clock face into 12 parts, each of these divided into 12, stretches of 5 minutes, or of 2½ degrees, each of these into 12 again, and so on. With our established time divisions, the 10 system can never be harmonized. The better unit of coinage is the American quarter, the English shilling, German mark. The dollar is too large, a fact in some measure responsible for the sinful and ruinous extravagance of American life. The shilling is already divided into 12 pence, a division that admits of no improvement. It remains only to be consistent, and to coin the 12-shilling piece, a convenient coin, which might be named twilling or telquar, with its fractions and multiples, which Anglo-American commerce would spread all over the earth. So, too, the foot is already divided into 12 inches. To convert inches and feet into each other, it would be necessary only to move the point. The meter has no superiority over the yard. If the latter be taken as standard, it should be divided into twelves, or telfs, and these again into twelfths, etc. The mile might be slightly reduced to 1,728 yards, in the tel system 1,000 yards, 3,000 feet. All such details and all proper preliminaries to the passage from 10 to 12 could be worked out by scientific committees appointed for the purpose, once the number 12 is laid at the base of our numeration, notation, and all forms of measurement, a position for which it is uniquely fitted. One and only objection can be made to this proposal, namely, that it is impractical, infeasible, and visionary. We dare not answer with the favorite scripture, "Where there is no vision the people perish," for this sentiment, alas, is foreign to the Hebrew proverb. But the objectors themselves reject with scorn the similar objection to the introduction of the metric system, that it is impractical and visionary, and could only with great difficulty be effected. It is the stock objection of all conservatism, the objection that confronts every effort to rationalize, humanize, beautify, glorify, and justify our life on earth, the objection that it cannot be done. The same has been said of 100 proposals, all declared unrealizable, and all now actually realized. It may be hard to answer Zeno's arguments against the possibility of motion, but it is none the less easy to move. So it will be with the change from 10 to 12. Attempted, it will be accomplished. Not in a day or a year, but at most in a generation. Let the children be taught the tel system year after year. The time necessary to learn it will be quite inconsiderable. Once learned, it will also be loved. In the meantime, scientific commissions can go over the whole ground carefully, and prepare the way in the wilderness, and level up in the desert a road for the age to come. When the change is finally carried into effect, the jar of switching off the 10 track to the 12 track will be much less severe than we now imagine. But it will bring incalculable blessings to all future generations. The great giant arithmetic will be shorn of half his terrors. It is very common in these loud-mouthed days to make Brobdingnagian pretensions. We are told that each of a score of trifles, baseball among them, won the war, when each made only a paltry contribution to the collective result. So we are assured that each of many things would have abridged the war by months or years. The World Trade Club informs us that had Congress adopted the meter-liter-gram legislation before Congress, 1904, the war would have been shortened 2 years. If a few other such things had been done, perhaps the war would have been stopped like Buck Fanshaw's riot, before it was started or even imagined. As much indebtedness heaps up on all sides, one is reminded of the famous couplet, "Owen More has run away, owin' more than he can pay." We are further assured that Clyde Wolf, master mathematician, University of California, writes, "A conservative estimate is that the exclusive use of meter-liter gram would shorten the time of teaching arithmetic to the average child by 2 years." If so, then the substitution of 12 for 10 as a base ought to shorten it by at least 4 years. No such claim is made here, but it is affirmed that a very large and sorely needed saving of time and energy would be effected, and that if the introduction of the thoroughly rational 12 system should be supplemented by the adoption of a thoroughly rational alphabet, with 1-to-1 correspondence of sign and sound, then would the words of the English language indeed be winged and fly over all the earth, then would our Anglo-American civilization lead the van of progress, and its commerce would fulfill the boast of its poet, "Trade is the golden girdle of the globe." End of Not 10 but 12 by William Benjamin Smith